Lesson: Blockchain and AI, Opportunities and Challenges. Blockchain and artificial intelligence, two of the most transformative technologies of the 21st century, offer unique opportunities and challenges when integrated into AI operations. This lesson explores the intersection of these technologies, providing actionable insights, practical tools, frameworks, and step-by-step applications for professionals aiming to elevate their proficiency in this domain. Blockchain technology, characterized by its decentralized, immutable, and transparent nature, provides a robust framework for enhancing trust and security in AI operations. The decentralized nature of blockchain ensures that no single entity has control over the data, making it tamper-proof and reliable. By leveraging blockchain, AI systems can securely access and share data across distributed networks, thereby reducing the risk of data breaches and fraud. For instance, in AI-driven supply chain management, blockchain can provide a transparent ledger of transactions, ensuring data integrity and traceability. This is particularly valuable in industries such as pharmaceuticals, where counterfeit products pose significant risks. One practical tool for integrating blockchain with AI is Hyperledger Fabric, an open-source blockchain framework designed for enterprise solutions. Hyperledger Fabric enables the creation of permissioned networks where members can collaborate on a secure, shared ledger. Professionals can use this framework to develop AI applications that require secure multi-party data sharing, such as federated learning models. Federated learning, a technique where AI models are trained across decentralized devices without sharing raw data, can benefit from blockchain's secure data exchange protocols. By using blockchain, organizations can ensure that the data used in federated learning is authentic and has not been tampered with. AI's ability to analyze and derive insights from vast amounts of data can significantly enhance blockchain applications. Machine learning algorithms can process blockchain data to detect anomalies, predict trends, and optimize processes. For example, AI can be employed to analyze transaction patterns on cryptocurrency networks to identify fraudulent activities or predict market trends. Additionally, AI can optimize smart contracts, which are self-executing contracts with the terms of the agreement directly written into code. By employing AI, smart contracts can be made more adaptive and responsive to real-world events, improving their efficiency and reliability. Despite the promising opportunities, the integration of blockchain and AI presents several challenges. Scalability is a significant concern, as both technologies require substantial computational resources. Blockchain networks, particularly public ones, can become slow and inefficient as the number of transactions increases. Similarly, AI models require extensive data and computational power for training and inference. To address these challenges, professionals can employ frameworks such as TensorFlow and PyTorch, which offer distributed computing capabilities. These frameworks allow AI models to be trained across multiple nodes in a blockchain network, improving scalability and performance. Another challenge is the lack of interoperability between different blockchain platforms and AI systems. This can hinder the seamless integration of these technologies into existing workflows. To overcome interoperability issues, professionals can utilize tools like Chainlink, which serves as a bridge between blockchain networks and external data sources. Chainlink enables smart contracts to securely interact with off-chain data, providing AI systems with access to real-time information from various sources. This integration facilitates the development of more sophisticated AI applications that leverage blockchain's security and transparency. Data privacy is another critical issue when integrating blockchain and AI. While blockchain's transparency is an advantage for data integrity, it can be a disadvantage for privacy. AI systems often require access to sensitive data, which, if stored on a blockchain, could be exposed to unauthorized parties. To address this, professionals can employ privacy-preserving techniques such as zero-knowledge proofs and homomorphic encryption. Zero-knowledge proofs allow one party to prove to another that a statement is true without revealing any additional information. Homomorphic encryption enables computations to be performed on encrypted data without decrypting it, preserving privacy while allowing AI models to process the data. Regulatory and ethical considerations also play a crucial role in the integration of blockchain and AI. The decentralized and global nature of blockchain can create regulatory challenges, as jurisdictions may have different laws and regulations regarding data usage and privacy. AI systems, on the other hand, must adhere to ethical guidelines to ensure fairness, transparency, and accountability. Professionals must navigate these regulatory and ethical landscapes by staying informed about the latest developments and adopting best practices such as conducting regular audits and ensuring compliance with relevant standards. The integration of blockchain and AI has far-reaching implications across various industries. In healthcare, for example, blockchain can provide a secure infrastructure for storing and sharing patient data, while AI can analyze this data to improve diagnostic accuracy and treatment outcomes. A case study from Estonia, which has implemented blockchain technology in its national health system, demonstrates how blockchain can enhance data security and interoperability, enabling AI-driven innovations in personalized medicine. In finance, blockchain's transparency and security can help prevent fraud, while AI can enhance risk assessment and investment strategies. AI algorithms can analyze blockchain transaction data to identify suspicious activities and predict market trends, enabling financial institutions to make more informed decisions. A notable example is the use of AI by cryptocurrency exchanges to detect and prevent fraudulent transactions, which has significantly reduced the instances of fraud and enhanced trust in these platforms. In conclusion, the integration of blockchain and AI presents both opportunities and challenges for AI operations. By leveraging blockchain's security, transparency, and decentralization, professionals can enhance the integrity and efficiency of AI applications. Practical tools and frameworks such as Hyperledger Fabric, TensorFlow, and Chainlink can facilitate the seamless integration of these technologies, addressing challenges related to scalability, interoperability, and privacy. However, professionals must remain vigilant in navigating regulatory and ethical considerations to ensure the responsible and effective use of blockchain and AI. By harnessing the potential of these technologies, organizations can drive innovation and create value in a rapidly evolving digital landscape.